Okay, so hi everyone. Welcome to the PCD of Codechef Starters 167. I am Pradyumn and this is TLE Eliminators. So let's start. Okay, so today we'll discuss the div 2 problems because that's what we do. In div 2 the first one was this one. Given a binary string S, we can perform the following operation as many times as we want. Choose I such that I is less than the size of the string and greater than equal to 1 and si is not equal to si plus 1. So basically you need to choose some I which is not at the end of the string and either delete si or si plus 1. Like they should not be equal and you can delete either of them from the string and concatenate the remaining parts of the string. So you have to find the minimum final length of the string s after performing some operations. Okay. So for example, let's see sample cases. In the samples we have like 1010. So for example, you have this string 1010. So first of all, what I could do is I could select these two, and since they are unequal, I can select them, and I can delete either one of them. So let's say I delete this one. So I'll be left with 110. Then let's say I choose these two. Then what I could do is I could delete this one. So it becomes 10. And then I can just choose these two and delete, let's say 0, then it becomes 1. So the length of the string is 1. We can't make it less than this because we cannot choose two adjacent numbers, right? And yeah, so like this is why the answer to 1010 is 1. Now for 00, the answer is 2 because you cannot do any operation because you have to select two adjacent indices with different bits, but there are no different bits in the string, so you cannot reduce the length than 2, right? And in the third one, like 00001. So in this case, what you can do is you can select these two and delete this 0. Then you can select these two and delete this. Then these two and delete this, and these two and delete either of them. Suppose I delete this, then I'll be left with just 1, right? So this is the problem. And like let's think what can we do about it. Like first of all, if all are equal, like if all are the same bit, either all 1 or all 0, then the answer is just n because we cannot make any operation, right? But let's say we have some different numbers, like if they are not all the same, if they are not all same, then what we can do, there will always exist some two indices where, like let's say this is a string. So if not all are the same, then either there will be 0 1 or 1 0 somewhere. Like what I'm saying is, in the string there will be either a 0 1 or a 1 0 somewhere in the string. Like it is not possible that they are not present anywhere. Like let's say 1 1 1 1 0. So you have this 1 0 here. So I want to say that either of these two are present. So in that case, what you will just do, you can just select these two, whatever is present. Suppose this is present 0 1, then you can select that. And since you can delete either one of them, you can just delete the one which is greater. Like either one of these will have frequency of greater than 1. Like if the string is, let's say, of length 4, let's say this is a string 0010, then you can select these two and you won't delete this one, because if you do that, then you will be left with 0 0 0, and you can't reduce that further, right? So that's why you will delete the one which has other occurrences. Like this 0 happens to be here also and here also, so that's why you will delete this 0. And again, like if you delete this 0, then again the invariant is satisfied. Like the string doesn't have all the same operations, all the same digits, so we can always do that again. we can do this operation until we are left with, like, let's say 0 1. Then we have to delete this 0, and we'll be left with 1. So my point is that if you have a string which is not the same, all the same, then you can make an operation and you will get a string which has not all the same. Like, for every string which has not all same, you can always make an operation which reduces the length by 1 and makes a string again who has not all same. So that's why you can just repeatedly do this operation on a string, and then it essentially will become 1 eventually. So therefore, if the all the characters in the beginning are not equal, then the answer is 1, and if they are equal, then the answer is n. So in case someone didn't understand this, I'll just dry run using a test case. So let's say we have 0 1 0 0 0. So in this case, we have 0 1 present. As I said, if all not all are equal, so either 0 1 or 1 0 is present. In this case, both are present. So 0 1 is present, right? So I can either delete 0 or 1, but I'll delete 0 because there are other occurrences of it. So I'll delete this. So the string becomes this. Now in this string as well, as I told you, not all are same. So 1 0 is present here. So I'll delete this 0 because other zeros are present. So I can do this repeatedly, and eventually I will end up with just a string of length 1. All right. But I cannot do any of this if initially the string given to me has all the characters same. So in that case, the answer is n. Okay. I hope it is clear. If it is clear, just give me a yes. Okay, and don't send me like the codes and ask me to find error in that. You can do that in the TLE's doubt section, because I cannot give time to just individual doubts, like, which do not benefit other students. Okay, so I'll just show you the code. The code is this, uh, c in t while t minus minus int and c in n, this is the input, and if, like, this is count function, it is an STL function that count the number of zeros or the number of ones, or like you can use it on any array. So it just counts in a given range the element that you want. So I just found the count of s0 in the whole string, and if it is equal to n, then that means that the whole string consists of only s0. So therefore the answer is n because it has all the same characters. Otherwise the answer is 1. Okay, the code is clear. Yes, okay. So let's go ahead with the next question. Lottery tickets. Uh, Wait, yeah. So the lottery tickets. Problem says there were n lottery tickets with numbers AI. Each number was distinct. Chef bought the first ticket A1. He is now wondering whether he won the lottery. Here is how the winner is decided. A number X is decided in the range 1 to 1e6, and then whoever has the closest ticket to X wins the lottery. If there's a tie, all of them are winners. So how many numbers X exist such that Chef won the lottery? So it is a problem that there are some number of lottery tickets numbered from A1, A2, AN. Like, there are n lottery tickets, and each one of them has a number written on it. which is 1 to n, like a1 to an, and each of these numbers are distinct. They are distinct. That is, there are no two indices on which the same number is written. Okay, and what is his name? Chef. Okay, Chef picks the first lottery ticket. So he is wondering that will he win or not. And the way someone wins is that basically a number x is chosen from 1 to 1 is 6. 1 to 10 raised to power 6, and the closest number to which x is in this array, he will win the lottery. And if there are multiple, then all of them will win. So we have to determine the number of x that chef wins with. Okay, so one approach that someone might think of is that we can just iterate over all the x's, then we can check if chef wins or not. So is there anyone who did that, who tried this during the contest? Yes, and you might have gotten TLE because you are iterating from 1 to 1 is 6, and for each x you have to check for n, like it is often. Okay, someone didn't get TLE, so probably you used binary search or something. Yeah, okay. That's the correct approach. I'm just asking that did someone iterate over all the elements and then just checked if someone, like, basically, let's say I check 5 and then I check if chef wins the lottery. Yes, brute force will give TLE. You can use binary search. But yeah, that was my point, that brute force will give TLE because the knife approach has complexity O of 10 raised to power 6 into n. Okay. But like, yeah, the correct approach is that what you are saying. I'm getting to that. I'm just telling that why will brute force give TLE? It is because the TC of that is 10 raised to power 6 into n, and the sum of n is 2 into 10 raised to power 5. So that is too much. Okay. So what you can do is you can, like, let's say we have a test case 5, 1, and 12. Okay, 5, 1, and 12. And chef picks this one, right? So out of all the numbers from 1 to 1 is 6, we have been asked that in how many numbers chef will win. So how do we figure that out? Let's say I plot this on a number line. I plot these numbers on a number line. So this is 1, this is 5, and this is 12. And chef picks this 5. So we have been asked to figure out that out of all the points on this number line from 1 to 1 is 6, like 1 is 6 is somewhere here, 1 is 6 is somewhere here. This is not drawn to scale, obviously, but since 12, this is 1 is 6. So out of all the numbers from 1 to 1 is 6, we want to figure out that for how many numbers 5 is closest out of all the other, out of all the lottery tickets, 5 is closest to, like, which points. So let's say we have 4. So if x is 4, then definitely 5 is the closest because someone else, like the other contender 1 is too far from 4. So 5 is the 5 is 5 wins the lottery. Then let's say we have 3. So 3 is equidistant from 1 and 5 both. So both will win the lottery. Then let's say we have 6. 6 is closer to 5 than 12. So therefore he wins. Then 7 is closer to 5. 8. 8 is also closer to 5 because it is distance 3. And this is distance 4. And but 9 is not. So basically our answer is from 3 to 8. That is 6 number of numbers. So the answer is 6. Now it is an observation that, like, I'll just draw this again. We have 1, we have 5, and we have 12, right? So definitely the points which lie here or which lie here before 1 or after 12, 5 can't be close to them. Like if I have a point here, then definitely 5 can't be the closest because 1 is closer than 5. So this range is not there, and after 12 is not closest to 5 because 12 is closer to this point as compared to 5. For every point that is right to the right of 12, we can eliminate them because all the points are closer to 12 than to 5. So we can eliminate this region. So what I'm left with is just this region that I want to check. So actually what you can see is the answer would be the midpoint of this to the midpoint of these two. Because to the right of this midpoint, the all the points are closer to 12 as compared to 5. And to the left of this midpoint, it is closer to 1, not 5. So I think it should be clear that from 1 to 5, the midpoint is 3. And from 5 to 12, the midpoint is 6.5. So we will take 6. Sorry, not 6.5, 17 or 8.5. So we'll take 8. So the answer is 3 to 8. So this is what I did, that I just found the midpoint and then the range, the length of that range is my answer. But what if it is the first element? Like let's say the test case is 1, 3, or let's just take some test case, 10 and 7. Okay. So we have 7 and 10. So basically, chef chose this one. So definitely, to the left of 7, answer is not there. We can reject. Between 7 and 10, there are some answers that are to the right of this midpoint. This midpoint is 8.5. So I can say that 9 or greater. Like I'll take 9. 9 or 10 is my answer. And to the right, all the numbers are my answers because every number to the right of 10, uh, for them, 10 is the closest. 7 cannot be closer to them because they are, it is clear, like it is visually clear, right? That 10 is the closest element out of the all. Like let's say I have 1, 2, 3. 1, 2, 3 I have, and I have chosen 3. So definitely all the elements that are in this range, like let's say somewhere here, X. So for them, for this X, definitely 3 is the closest. So this is the observe, like this is obvious, I think. So that's why you need to handle the cases where either the element that chef chooses is first or it is last. You have to handle separately. Like let's say it is last. Let's say in this test case we have 10 and 7 and 10, right? So 7 and 10. So definitely all the numbers from 10, or let's say 11. From 11 to 26, all are my answer, right? So this means 1 is 6 minus 11 plus 1, the length of this interval. And in this range, from between 7 to 10, my answer would lie in 9 and 10. Like 10 plus 7 by 2 was ceiling. This is the midpoint. And I am taking ceiling because this is the left one. So from this to 10, so this is basically 17 by 2, 8.5, 9. So 9 to 10. So we have two length. So the answer becomes, this is 99990 and this is 2. So this becomes the answer. Now when I am taking ceiling, like why am I taking ceiling? I'll explain that quickly. So for example, you have 5, then you have 10, and then you have 15, and you chose 10. So in this range, like from 5 to 10, this is the midpoint. Midpoint is 7.5. So all the points right to this are my answer. So definitely I'll start with 8, not 7, right? Because 7 is not my answer. 8 is my answer. So I'll start with 8. So this is the ceiling of 7.5. But here, in this side, midpoint is 12.5. Midpoint is 12.5. So all the elements are left of 12.5 are my answer. But so basically, I'll just count from 12 because I can't count 13 obviously. The 13 is outside the range. It is right to 12.5. So I won't count 13. I'll start from the like from 10 to GIF 12.5. So that's why let's say we have taken some k, or let's say we have taken the ak as element. So before that there is ak minus 1, and after that there is ak plus 1. So I will just add this to my answer. The ceiling, like the midpoint of these two, that is ak minus 1 plus ak by 2 ceiling to the GIF of these two, this point midpoint, which is ak plus ak plus 1 by 2. So this is my answer if the element that I chose is not the first or the last. And if it is the first or last, then I will have to handle it separately. Like let's say it is first, then for the left, like let's say it is some, it is a1, right? So it is a1. So I'll just add 1 से लेके a1. Okay, and then let's say there's a2, some a2 here. So we'll also add a1 plus 1 to the midpoint, the GIF of a1 plus a2 by 2. So this is the case where the element is first. And if the element is the last element, then the similar thing, like if this element is, let's say, an, then I'll add from an to 26. I'll add from an to 10 raised to power 6. This is one answer. And the other answer is like there is some element a n minus 1 here. Then the midpoint is a n minus 1 plus a n by 2, the ceiling. So from this to a n minus 1, I will add to my answer. Because a n I've already added, so only till a n minus 1 I'm adding. So this is how you handle the HCSs. Someone is saying we can insert 26 at the end of the vector, then this will be covered. Okay, interesting. If we add 26 at the end, then which case will be covered? Can you uh, clarify? If we insert 26, uh, I don't get it actually. Like, how does that work? You want to unmute yourself. Okay.
Hello, am I audible?
Yes, yes.
What I was thinking was of like if the element we are searching for is the last element and we don't have any further elements after that. But
Hmm.
initially in the vector, if we insert 26, then our right element will always be there, right? Like this cannot be the case in which we do not have a right element.
But then the answer will get changed because uh, the last let's say the last element is 9, highest element is this. This is 26 minus 10. And then you insert 26. Then you will report the answer this to 99995. But this is wrong because you can go up to 26 now. So this is uh, not a wise idea, like because it gives the wrong answer. Anyways, so I just in my code I just handled three cases, and also have to handle where n equals to 1 separately because uh, but yeah, first of all, basically how do you figure out where my element is? Like let's say we had the initial array a1, a2, an, and we are picking a1. So how do we know that after sorting where will the a1 end up? Okay, we can traverse the array or we can binary search. We can use lower bound. Yeah, we can store a1 in some variable k, and then we can use lower bound for k. So in case this lower bound returns the beginner iterator, that is the first element, then we'll have to handle that separately. Or if it returns previous of end, then the same thing separately. Yes, because all elements are distinct, so we can do this, right? So I think it should be clear that we can just find the index by lower bound. Okay, someone used single loop without sorting by tracking max, less, and min bin. Yeah, you can do that as well. Okay, yeah, that is O of n. मतलब ठीक है, that is in O of n. Mine is n log n. I mean, yeah, that is smart. That basically what this guy did, we just wanted, like in the sorted array, we just wanted the previous number to my number. Like since my number is AK, so I just wanted the previous that is just smaller than AK, the highest one, and AK plus one, which is just greater, the smallest number just greater than AK. So he found that using just a single loop, he just kept two variables, uh, like smaller, like max, less, and min bin. So, and then he'll just use those two variables to calculate the answer. That is also okay. Use find function. Yeah, that is also O of n without sorting. Yeah, whatever you wanna do. So, anyways, I'll just share my code. Mm, Okay. So we have this code. I input the array, then k is equal to a0. Then I sorted the array. Now if n equals 1, then I just printed 1 is 6. Because for every number you will just win the lottery. He will win the lottery because he is the only one. Like the only ticket is closest, obviously. Then um, like yeah, if k is the last element after sorting, then I added k to 1 is 6 and the left bound, which is this, to k minus 1. And then I printed it. Now if a0 equals to k, that means the smallest element is k. Then also I handled it like I added 1 to k, and then I added k plus 1 to this number. Like this is GIF, and this is actually ceiling, as you can see, because I added the plus 1 here. And otherwise, I just search for k. This is the index. IT is the index in the array. So low means my left index, that is the ceiling function of previous plus my element plus by 2, and high upper limit is this floor by 2, and see out high minus 2 plus 1, the length of this interval. Someone is asking, can we use ceil and floor function? Actually, it is not recommended to do that because those functions work on floating point numbers. Like their input is float or double, and the returns float or double, as you can see. Like you could see clearly in VS Code or wherever you type in the in the suggestions, you will see that they return a float. So sometimes a floating point error might happen in that. So it is always better to use like directly divide by the number if you want GIF. Like if by default it gives GIF for positive numbers, it gives GIF by default. And to get ceiling, you can just do this a plus b minus 1 upon b if you want the ceiling of a by b. But do remember that for negative numbers, it doesn't work that way. Like if you do, wait a minute. My whiteboard stopped working for some reason. Just a minute. Yeah, okay. So if you do minus 5 upon 2, then in C++ it will return you minus 2. And if you do minus 4 upon 2, then of course it will return minus 2. But like in negative numbers, it returns the ceiling. So be careful in that. For positive numbers, that as you know that let's say you do 5 by 2, then it returns 2. It returns the floor, but not the floor every time. Like if it is negative, then it will return the ceiling. Like basically, it just cuts off the floating point. Minus 5 by 2 is technically minus 2.5, but it just cuts this off and returns you minus 2. Okay, so keep this in mind. Sometimes you might get wrong answer due to this fact. All right. So is it clear, or is there any doubt in this problem? I'm not getting any doubts, so I'm assuming that it is clear. Okay. So yeah, the next problem, what is grid construction odd? Okay, so um, you are given an odd integer n. Your task is to construct a grid A containing n rows and n columns such that for every ij, aij has to be between 1 and n. All the elements of the matrix have to be between 1 and n. Then for every x appears exactly n times in A. Like there are n square elements. If a matrix is n by n, then there are n square elements in this. So each element should occur n times. That's what it is saying, that each element from 1 to n should occur n times. Then let S1 be the sum of elements in the diagonal from top left to bottom right, and S2 be the sum of elements in the diagonal from top right to bottom left. Then sum of all elements in every two adjacent rows has to be equal to S1 plus S2, and sum of all elements in every two adjacent columns has to be equal to S1 plus S2. So you have to construct a grid which satisfies this property. Like the property is, let's say we have n equals to 3, then basically S1 is the sum of these three, and S2 is sum of these three. So what they want is that the sum of these two columns should be equal to S1 plus S2. Sum of these two columns should be equal to S1 plus S2, and the sum of these two rows and these two rows should be equal to S1 plus S2. That is the condition for this. Okay. So how do we solve this? Let's think. So first of all, like when I solve the problem, I just thought about what if I make every row and every column a permutation. Like let's say in the first, basically what if I do that in every row and every column there are n distinct elements, like from 1 to n. So if I try to make a matrix like that, so first I made this matrix for n equals to 3. I did 1 2 3, then I did cyclic shift of that. So this is 2 3 1, and then 3 1 2. So in this matrix the elements are like this, where each row and each column has all 1 to n. So definitely the sum of these two and sum of these two is the same, definitely, as you can observe. Could I please repeat the question? Okay. So basically we have to construct a grid of size n by n, let's say 3 by 3, where the constraint is that all the elements should be between 1 to n, and each element should occur n times. So there are n square elements. So each element should occur n times, and they should be between 1 to n. Okay. And the condition that should be satisfied is that, let's say the sum of diagonals is like of this one is S1. This is S1, and sum of diagonals of these three elements is S2. Then you have to ensure that sum of these two rows is equal to S1 plus S2. Sum of these two columns is equal to S1 plus S2. Then these two rows also S1 plus S2, and these two rows also. Like all adjacent rows and columns should have sum equal to this. So this is the problem, and I was like explaining the my thought process. Okay, so like first of all, I want to ensure that the sum of these two equals sum of these two, and sum of these two equals sum of these two. So what I tried was to make the sum of everything equal. Like I just tried to make the sum of everything equal, like n into n plus 1 by 2. Basically, I just tried to put all the elements in every row. Like every row should have elements 1 to n, and every column should have elements 1 to n. So to construct that kind of matrix, what I did was I just I just did like this. That in the first row I wrote 1 2 3. Then next one I wrote cyclic shift of it. I just shifted this row to the left cyclically. So this becomes 2 3 1. And then again I shifted to the left, so this becomes 3 1 2. So it satisfies the property that, yeah, the grid is wrong. I'm getting to it. So it satisfies the property that every row and every column has 1 2 and 3. But the thing is that the sum is not equal to what we want, because the sum is 6 for every row. So for every adjacent row, their sum is 6 plus 6, which is 12. Like for every adjacent row and column, their sum is 12. But what we want 1 plus 3 plus 2. Like S1 is 1 plus 3 plus 2, 6, plus S2 is 3 plus 3 plus 3, which is 9. So which is 15. So this is the wrong, because the sum of adjacent rows and columns don't add up to S1 and S1 plus S2. Okay. But um, I observe that what I can do, I can just change this S2. Like if I basically what I am trying to do, that everything should have n. Everything should have 1 to n. So I have satisfied that this row, all these rows and all these columns have 1 to n. Now I just want to do that the sum, actually in diagonals, what if I ensure that like 1 to n the sum is 6 now? 1 plus 2 plus 3. In this case, the sum is 6. So what if I try to make this sum 6 and this sum 6? So in that case, it would satisfy, right? So I just thought to myself that how would I make this sum equal to 6? How, like this sum is already equal to 6, right? But how do I make this one equal to 6? I can just keep the elements 2 instead of 3. So basically, wherever there is 3, I just kept 2. And wherever there is 2, I kept 3. Like in this matrix, what I did was I swapped two and all the 2's with 3's and all the 3's with 2's. So if I just show you, uh, here all the 2's with 3. So 1, 3, 2, 3, 2, 1, 2, 1, 3. So like why I did this? Because it maintains the invariant. Like every row has all from 1 to n, right? So if it has all from 1 to n, then swapping 2 and 3, after that it will also have 1 to n. Like it is pretty obvious that suppose we have 5, 1, 2, 4, 3. Then changing this 2 with 3 and 3 with 2, it will still have all numbers from 1 to n. So it doesn't harm us. So I can do this. So I just did this and it resulted in this diagonal being 6 and this being 6. So and all the rows are 6. I mean the columns and all the rows also are 6. So everything is 6. So if you like add two adjacent rows, then it is equal to 12 and S1 plus S2 is also equal to 12. So I can construct this for odd. So in general, so to code it actually in general what we can do. So if we have n and n is odd, so in each row the sum should be n into n plus 1 by 2, right? So what I will just do is that I'll fill this matrix with like the first row will once say n, then second row I'll cyclic shift to the left. So it will be 2, 3 up to n and then 1 and so on. But I just need to figure out that which element should I replace. Like in the general case, every element on this diagonal will be n. It would be n, right? Do you get this? Like if I make an n by n grid using this method, then every element on this diagonal will be n. So do you get this part? It is 3 right now, but it will be n in general case. So I just need to figure out that which element should I switch it with. Like in this case, if I keep 2 here and in place of 2 I just place n, then I will get my sum. That's what I told you. But in general case, how do I figure out that which element should I keep here? So to do that, yeah, so the sum I want for each row and each column is this, and each diagonal also. So I want this sum, and let's say I keep the element x here. I keep the element x. So x occurs n times, right? There are n elements in this diagonal. So the sum of this diagonal is n into x. So n and n cancel out. So I will get x to be equal to n plus 1 by 2. So therefore, I should, first of all, my algorithm will be, I'll make this matrix. I'll make this matrix of n by n, where the first row will just be 1 to n, then all the other rows will be cyclic shift. Okay, so 1, 2, 3, 4, 5. This is cyclic shift to the left. So 1, 2, 3, 4, 5, 1, and so on. And then you can see that every element on this diagonal is 5. So I'll just replace it with n plus 1 by 2, right? Which is 5 plus 1 by 2, which is 3. So I'll just replace all of these 5s with 3s and all the 3s with 5s. And I'll just print the matrix. But actually, how to implement this? This is actually a good problem. That how to implement. Actually, there's a very nice trick to this. Like you can use the mod operator. This mod operator you can use. How? Let's see. Let's say you want to make 3 by 3. This is 0, this is 1, this is 2. In 0 indexing, this is the thing 0, 1, 2. So, this is my I, right? Let Aij be right now. So, this is my I, and this is my j. So, guys, if I just put Aij, like basically in first row, what do I want? In first row, let's just say for now, I wanted to print the numbers from 0 to n minus 1. Like just for now, just assume that instead of 1 to n, I want the elements to be between 0 to n minus 1. So what I can do is in the 0th row, this is I equal to 0, I can just put j, right? Because it is just 0, 1, 2. Then the first row, I can't put j because this there I want 1, 2, 0, right? In the above one, I had put j, which is 0, 1, 2. Then I want to shift it to the left, cyclic shift. So I will have to put 1 to 0. But how do I do that? I can just add 1 to these elements. I can just add 1 to 0, 1 to 1, and 1 to 2. So 1, 2, and 2 becomes 3, but we want 0. So actually, we can just take mod n. Like we want 0 to become 1, 1 to become 2, and 2 to become 0. So this is just mod 3, adding 1 mod 3. So we can just add 1 to the previous elements. Then in the second row, we can just add 2, like, to these elements. To 0, I can add 2. To 1, I can add 2. So 1 plus 2 is 3. Mod 3 is 0. And to 2, I can add 2. So 2 plus 2 is 4. Its mod 3 is 1. So essentially, I have shifted this row 2 times to the left. So basically, I am just filling column. Like if you can see that in the 0th row, I just filled j, 0, 1, 2. Then here I filled j plus 1. In the first row, I filled j plus 1. Then the second row, I filled j plus 2. So in general, I am filling j plus I for the ith row. And of course, mod n. Aij is just j plus I mod n. And then if we want to shift it, like this is, we have made this from 0 to n minus 1, right? So we can just add 1 to this. So it will make it from 1 to n. So if we just do this for all ij, then we get that matrix which is wrong, right? You will get this wrong matrix. So after this, we just need to swap these two elements. We just need to swap n plus 1 by 2 with n and n with n plus 1 by 2. Like all the diagonal elements, all of these twos, or let's say threes, right? Because I did this plus 1. So the matrix will become like uh, 1, 2, 3, 2, 3, 1, and 3, 1, 2. So I just need to swap all of these n's with n plus 1 over 2 and all the n plus 1 over 2's with n, and I'll just print my answer. Okay, so I think that is straightforward to do. You will just loop through the entire matrix, and if it is equal to n plus 1 by 2, then you'll put it to be n, and if it is equal to n, then you'll put it to be n plus 1 by 2. So I think that should be clear. So is the whole problem clear to everyone? Or is there any part which you did not understand? Is there any unclarity or any doubt in anything? You can ask now. How the intuition came? The intuition for which part? Can I summarize? Okay, I'll do that after the intuition. Permutation part, swapping n with n by 2. Um, I mean, that is like basically what I observed was that in every row and in every column, since I had all of the elements, then their value doesn't matter actually. Like if you have all the elements from 1 to n, then what is it like this 1, this 2, this n? Even if I write this as something else, like even if I write 1 as square, 2 as circle, then triangle, like, and this as this, like, all of these are distinct. That's what matters. This 1, 2, and are just symbols. So I can replace them with anything. So I wanted to make the sum equal to 6. So that's why I replace them with 2. Because I can do it. I can replace them with anything. I just want that they have all distinct elements. So I just replace them with 2, and the 2 that was there, I replace it with n or with 3. Okay, I'll summarize now. Like summarizing, I'll just make it for 5 by 5. Okay. So what I did was I filled the first row from 1 to 5. Wait a minute. 1, 2, 3, 4, 5. Then I cyclically shifted to the left. Like first of all, I just made all of the rows and the columns distinct. All the numbers in every row should be distinct. So I made kind of that 3, 4, 5, 1, 2, 4, 5, 1, 2, 3, 5, 1, 2, 3, 4. Then I observed that this diagonal is okay, but this diagonal has all fives. So I just need to change so that the sum of this diagonal becomes n into n plus 1 by 2. So therefore I change this n with n plus 1 by 2 and n plus 1 by 2 with n. So I just swapped all the fives with threes and threes with fives. So this is what I did, summarizing. So is it clear? Someone is telling the solution. I filled diagonal with n plus 1 by 2 first, and for filling the rest, I was filling with permutation of all elements except n plus 1 by 2 element. But for some row and column, elements were repeating. Yes, they will repeat. So, like, was it correct? Did it get AC? Or no, it didn't get AC. Okay, yeah. The sum must not be equal to the diagonals. Even one is different. Yes, that is a different problem. And this algorithm doesn't work in even. I'll discuss the even one next. Once we are all clear on the odd one. So is the odd one clear to all? हाँ यार ना बोल दो भाई. I actually came up with similar kind of approach for even one. Okay, that's great. But I'll just tell my approach, and then if we have time, then we'll hear yours. Okay. Can you show the code? Yeah, I'll show the code. Okay, let's move on to the code. Yeah. So initially, I just filled the array with this I plus j mod n plus one. As you could see here, I explained here. Aij equals I plus j mod n plus one initially. Okay. Then I loop through the array or through the matrix, and if Aij equals n, then I set it to be n plus 1 by 2, and if it was n plus 1 by 2, then I set it to be n. And I wonder why this compiled, because I am missing a bracket here, I think. Okay, no, I'm not. Anyways, so yeah, else if, like, basically if Aij is n, then I replace it with n plus 1 by 2, and if it is n plus 1 by 2, then I replace it with n, and then I just print the answer. This is the code. So is the code clear? Yes. Okay, very nice. So next problem, like the most solved one is temperature balance, but I'll do that later. I'll skip to this even construction one because it is similar to this one. So we'll do this one first. So the same problem, but for n equals even. Okay, the problem, the same problem, right? Actually, in the previous one, I just made all the row sums and column sums and diagonal sum equal to 1 to n, like the sum for 1 to n. The sum for 1 to n is n into n plus 1 by 2, right? So I just made all the row sums, all the column sums, and both diagonal sums equal to this. But probably if even is harder and lower people solved it, I thought that probably it isn't possible. It is not possible to make this, that all the rows have this sum, all the columns have this sum, and all the diagonals have this sum. So I thought that it mostly isn't solvable. It isn't possible to make all the sums equal. But the constraints, like the rules that the matrix must follow, they are not those. Like they are somewhat looser than what I solved for. In the odd one, I just made all of them equal. But we don't need all of them to equal. We just need that the sum of two should be equal to the sum. Like basically, let's say 4 by 4. So we just need that these two ka sum and 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 these two and these two ka sum, they all should be equal to these two ka sum. So that doesn't actually mean that we need all of them to be equal to this quantity right here. and I assume that it is not possible. So, anyways, like they just want these adjacent rows ka sum to be equal to this diagonals ka sum. So, how do I solve this one? Actually, I got stuck on it for quite a long time. That's why I couldn't solve the next problem. Like this one is also kind of easy, I think, but I couldn't solve it because I was low on time because I took too much time on this. But anyways, what I thought about it, like I actually thought many things. Some of them didn't lead anywhere. But anyways, I'll just tell you the one. I'll just tell you that thought process, the whole thought process, which led me to the answer. Okay. So, okay, let's say we have this 4 by 4 grid. Let's say the row sum of this row. This is R1. The sum of this row is R1. Sum of this row is R2. This row is R3. And this row is R4. The sum. Okay. So what do we want is that R1, sorry, R1 plus R2, R1 plus R2 should be equal to this, and should be equal to this, should be equal to R2 plus R3, and this should be equal to R0 plus R4. Isn't this true? So if this is true, then what does this tell you? That R1 should be equal to R3. The row sum for R1 should be equal to R3, and the row sum for R2, like these two equals tell you that R2 should be equal to R4, right? So like seeing all of these equalities, I just thought that let's just keep them that let's just keep it all to be equal and the sum from 1 to n. Like if they're all equal, then obviously let's say they're equal to a. Okay. So actually, if they're all equal to a, then n into a is the total sum. If there are n rows and they're all equal to a, so the sum of the whole matrix is n into a, and that should always be equal to um, n square into n plus 1 by 2, right? Because we have all the elements from 1 to n, and all of them are n times. So the sum must be equal to this n square into n plus 1 by 2. So that's why if I want all the row sums to be equal, then they have to be equal to sum from 1 to n, right? They have to be equal to n into n plus 1 by 2. They have to be equal to n into n plus 1 upon 2, right? Now, um, also for the columns, I also assume that let's just keep the sum n into n plus 1 by 2. And the easiest way to do that is to ensure that all of the rows and the columns have all the numbers from 1 to n. So yeah, basically in this one also, I tried to construct something in which all the rows have 1 to n, all the 1 to n numbers, and all the columns they also have 1 to n numbers, right? But the thing is that how do I make it? Like I also have to ensure that the diagonal sums, basically the sum of this diagonal plus this diagonal, this should be equal to n into n plus 1 by 2 into 2. है ना? Because we want the adjacent column sums and adjacent row sums to be equal to S1 plus S2, right? Let's say we have all of them equal to A. Like we have C1 equal to C2 to Cn. All of these are equal to n into n plus 1 by 2, right? So, and the constraint in the problem was that sum of all elements in every adjacent columns have to be equal to S1 plus S2. Like what we want is that C1 plus C2, that is n into n plus 1 by 2, sorry, n into n plus 1, that should be equal to S1 plus S2. So what that means is the sum of diagonals, this one and this one should be equal to n into n plus 1. This is clear, right? So I just tried to make construction where all the rows are from 1 to n and all the columns are from 1 to n. And the sum is equal to n into n plus 1 of these two diagonals. These two diagonals. Okay. Now to do that, you have to look at this image a bit differently. What I mean by that is, I'll just redraw it. These four. Now I'll just mark all those vertices or all those cells which are included with red. This cell, like the first diagonal has these four cells, and second one has these four cells, right? So basically, I want the sum of these cells to be equal to n into n plus 1. And also I want that in each row and each column, all the numbers from 1 to n should be there. That constraint is there, but also you want the sum of all these elements to be n into n plus 1. So just forget about the diagonals, like these lines, this one line and this other line. Just forget about these two lines. Just look at this image. Look at this whole image and look at these cells that you want to fill. All right. And just think about how can you make their sum equal to n into n plus 1 while also maintaining that all rows and all columns should have numbers from 1 to n. So how will you do that? Actually, forget about those two lines. You forgot about these two lines, right? Now think about these lines. This is a hint. I'll give you 2 minutes to think about it. Just think about these two lines, like these four lines, and just think that how will you make the sum equal to n into n plus 1? So is there anyone who is getting an idea or something? Okay, I'll just uh, try to explain. Like we have n equals to 4, right? So we have these four numbers to fill. Okay, someone says fill one diagonal with 1 and 4, other one 2 and 3. But what will you do if for 6? Like, you cannot actually action this idea. What will you do for 6? Because in that case, there are 6 numbers that you want to fill. 1, 5 and 3, 3. 3, 3? You mean 3, 4? Or what do you mean? 1, 5 and 3, 3. Actually, there might be many answers possible, but I'll just explain mine. Okay. So what I actually did was just look at these cells. Okay. You want to make sure that the sum of all of these entries is equal to n into n plus 1. So what you can actually do, just look at every column. Like look at this column, look at this column, look at this one, and look at this one. You can observe that in every column there are two of these cells. These red marked cells, there are two of them, right? In every column. So actually what you can try is just keep a number here. Let's say you keep 1. Then just keep a complement of that in here. So that their sum is n plus 1. Like for example, if you keep 2 here, then you will keep 3 here, so that their sum becomes 5, which is n plus 1. So for each column, if you do that, then you can just make sure that this satisfies. Like let's say we just fill the top half, and then like basically if we satisfy that, what we can actually do is we can just fill the top half as we like. So let's say we fill the top half with just cyclic shift 1, 2, 3, 4, 2, 3, 4, 1. Then what we need to ensure that the complement of this one gets filled here, complement if this 2 fills here, then complement of this 2 fills here, of this 3 fills here. So if we do that, then the sum of diagonals will definitely be this n into n plus 1. I like it should be clear. Wait, I'll just explain it once more. That you have this grid, right? 4 by 4 grid. So in this grid, you have these cells that you want to fill. I mean that thus like their sum will be counted. So their sum should be n into n plus 1. So if you just ensure that sum of these two is n plus 1, sum of these two is n plus 1, these two is n plus 1, and these two is n plus 1, then definitely the sum of all of them will be n into n plus 1. So what you can actually do is just fill the top half. Just fill the top half and then take the complement of for that. Like 1, 2, just fill it arbitrarily so that you don't repeat it. Like let's say 4, 3, 2, 1 also I can do. So I'll just fill the complement of all of these in the bottom. Like of complement of 1, I will fill here. So that when they add up to n plus 1. So here I will fill. Actually, I can't do that because 4 I have filled here. But okay, so I will ensure I'll just do like this. Wait a second. What I did was, yeah, actually you can't fill up. You have to ensure, like, see, you have the numbers 1 to n, where um, n is even, right? So the numbers 1 to n by 2 are in the lower half, and n by 2 plus 1 to n, they are in the upper half. So actually what I did was 1 complement n, right? What did I do? Actually, I just filled this, like, I just filled these cells with lower halves, like 1, 2, 2, 1. And then I filled their complement, like 1 complement is 3, or sorry, 4. And 2 complement is 3. Then this 2 complement is 3. 1 complement is 4. And then also I just did complement here, like in these two cells. So I filled 4 and 3, 2, then 1. And for these two also. So 3, 4, 1, 2. Like I'll explain for 6 by 6, it will be clear by that. Like, what I did was I just draw 6 by 6 grid. Yeah, so there are 1, 2, and 3 in the lower half. And then we have 4, 5, and 6 in the upper half. So what I did was I filled these cells with lower halves. Like this cell, and this cell. Right? Right, like here I filled 1, 2, 3. Then here I filled 2, 3, 1. And here I filled 3, 1, 2. And then to fill the rest of them, I just did the complement. Like to fill the lower half, I just took the complement of 1, so which is 6. Complement of 2 is 5. Complement of 3 is 4. And complement of 1 is 6. Like these two. Then for these two, I did 4. Then here I filled 5. Then this is 5. This is 6. This is 4. And to fill this row also, I just did complement. So this ensures that I don't repeat any number in any row or column, because I have reserved the ones, like I have reserved these cells for lower half. Actually, I have reserved all of these cells for lower half. So definitely, these cells will definitely contain upper half. So that's what I did. And here I can just fill in the complement of the left ones. So 1 ka 6, 2 ka 5, 3 ka 4, 2, 1. The complement is 5, 2 ka 4, 6, 1, 3, and 2. 4, 6, 5, 2, 1, and 3. So actually, this is what I printed for 6. Like the core idea is that you just need to take the complement. Like the upper half and the lower half should be mirror image of each other. Not really mirror images, but like whatever you write in the upper half, in the lower half, it should be like the complement of this cell is this cell. Or do I confirm for diagonals? Yeah, so that's what I am saying. Like from the condition of diagonals, I got this construction. Like for 4 by 4, 1, 2, 3, 1, 2, and 3. For 4 by 4, the cells matter. This is the first diagonal, and this is second diagonal. Yeah, got it. Got it. Okay. So, is there any part in which someone has a doubt? Like, of course, there are many constructions for this problem, but I just told you mine, what I did. Like anything which gets accepted gets AC is correct, obviously. But this is what came to my mind, and that's what I told you. And how I thought also, like how I thought about it, that's what I told you as well. So if you have any doubt in those parts, then let me know. And if you're watching on YouTube, then you can also let me know in the comment section. Okay, if no one has a doubt, then I can just show you the code for this thing. So in the code, actually, before showing the code, I'll just brief you about what I did. I just filled alternate columns. Um, like I filled this column upper half and this column upper half by the lower half numbers, like the numbers from 1 to n by 2. I filled them in here. Or let's say in 6 by 6, what I did, the same thing. That 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So yeah, in alternate columns, like in these three cells, like in the first column, third column, the first three cells, and this last column, I just filled these. I just filled these with um, the lower half elements. That is 1, 2, 3, then 2, 3, 1, and 3, 1, 2. Then I took the complement of this here, of this here, and of this here. So this whole row is filled. I mean, these all three columns are filled, and to fill the rest of the columns, I just took the complement of the left. Like in this column, I just took the complement of the left column. Of this column, I took the complement. So I'll just show you the code. So yeah, j equal to 0, 0, 0, and j plus equals to 2. So I'm iterating over these columns, the alternate columns, this 0th, second, and fourth. Then for LL I equals to 0, I less than n by 2, I plus plus. So the first n by 2 columns, I am filling them with I plus j by 2 mod n by 2 plus 1. So this is similar to the first, like the odd case. Like if I show you that, um, just a minute. Yeah, okay. So in every column, like I filled these three, and these three. So how did I fill? I just filled them cyclic, like by the same thing as in the first, the odd one. Like I filled 1, 2, 3 here. So basically, which means I, like here I is 0, 1, 2, 3, 4, 5, right? This is I. So I just filled I plus j, I plus j by 2 actually. So j is 0, 1, 2, 3, 4, and 5. So in 0th one, I just filled 1, 2, 3. In 2, 1, I just added 1 to this. So 2, 3, and 3 becomes 1. So I just take mod by 3, which is n by 2. And so basically what I did, I just added I plus j by 2. Like this is what I filled with. I plus j by 2 mod n by 2 and plus 1. No, we will discuss one more problem. We will discuss the problem which I skipped previously. We'll discuss the temperature one. So yeah, anyways, what I was saying that I just filled these with those numbers, and you can check by yourself that it was the correct. Then for the remaining cells in that column, like first I filled these cells, then I filled these cells. So in this for loop, I am filling these cells. So like for aij, I am taking its complement. I am taking n plus 1 minus a of n minus 1 minus I comma j. So in this cell, let's say I am filling the complement of this cell. Okay. So this is how this is like now all of these columns are filled. Then for the rest of the columns, like j equal to 1, j less than n, j plus equals to 2. Like for these columns, the odd columns 1, 3, and 5, I just filled it with the complement of the previous one. So aij equals n plus 1 minus a I comma j minus 1. So the previous columns corresponding cell, and its complement is just n plus 1 minus that. So I just printed the matrix. This code might be somewhat tough to understand if you are looking at it for the first time. So I just recommend you all to go through it once the class gets over and see how it works. Like I just told you, like my algorithm, and you can verify by yourself that this code prints that algorithm. This code goes hand in hand with that algorithm. So you can verify that by yourself. Okay, so let us just move on to the last problem of this discussion. The problem is temperature balance. Okay, so let us move on. Let us read the problem. There are n chambers of water in a line. Between the i's chamber and the I plus 1 chamber, for each I from 1 to n minus 1, there is this wall. There is a wall blocking the heat from moving between the two chambers. The water in the ith chamber uh, the water in the ith chamber has a temperature of AI. Additionally, it is known in advance that the sum of AI is 0. Okay, so there are some um, chambers of water. Okay, so there are some chambers of water. Let's say n chambers. So we have some walls between those chambers. Okay, and those walls prevent the heat from flowing from one chamber to the other. Okay, so each chamber has a temperature of AI. So this has temperature of A1, temperature A2, and temperature A3, and so on. Right? Each chamber has a temperature, and the sum of temperatures, sum of AI, is given to be 0. Okay. Now each second, you lift exactly one wall, letting heat move between those two chambers. Like if you remove this wall, then these two chambers become one, and heat will move from one to the other. And as you know that heat moves from the hotter to the lower, like hotter to the colder. So therefore, the temperature whose the one who is higher will get lower, and the one who is lower will get higher. So that's what will happen, that the temperature level of the hotter side decreases by 1, while that of the colder side increases by 1. Formally, they have given it is not, it is the same thing. After the second, the chamber closes. So, like in one move, like in 1 second, you can just do that. You can remove a wall and let the temperature flow. Let's say from A3 to A4. If A3 has more heat, then temperature of A3 will decrease and A4 will increase. So like they will go towards stability, kind of, you can say. So please find the minimum number of seconds needed to make all temperature levels exactly 0. It can be shown that it is always possible to make all temperatures to 0 in finite number of seconds. Yeah, so the problem says that there are some temperatures, there are some chambers, and we have to make all of them zero. And to do that, in each second we can remove one wall. Let's say I remove a wall. Let's say I remove this wall. Then these two chambers will exchange heat, and heat will flow from the higher to the lower temperature, and the change will be one. Like the hotter one will decrease by one, and the lower one will increase. So we have to figure out the minimum number of seconds that we need to make all temperatures equal to zero, right? Okay. So how do we do this? Let's just discuss the samples. Let's say we have 100 minus 1, 100 and minus 1. So actually what you can say is this water and chambers thing is just very confusing. So I'll simplify it. I just simplified that we have an array, and in one move, or let's say we don't have an array, we have okay, let's say we have an array. Never mind. We have an array, and in one move, what we can do is we can decrement an element by one and increment the other by one. Like any two adjacent elements, we can choose two adjacent elements. We can decrease the higher one by one and increase the lower one by one. Right? So let's say we make a move on this two. So they will become 0, 1, 0, minus 1. Then let's say we make a move on these two. So they will become 0, 0, 1, minus 1. So kind of we are bubbling this 1 towards this minus 1, right? And let's say we make a move on these two. So they will become 0, 0, 0, 0. So the whole array becomes 0. Within 3 seconds, this whole array becomes 0, right? So that's why the answer to this test case is 3. Okay. So if you can visualize, we are kind of um, what we are doing is that there is a negative here which we want to neutralize. So therefore we will search for a positive number. So let's say this is a positive 1. So we will kind of bring it towards this minus 1. So this 1 is coming towards this minus 1, and finally they merge to become 0. So let's say we had something like 2, 0, 0, and minus 2. So since we have this negative here, we need a positive to neutralize it. So we will just bring some heat from there. So like first we'll bring this 1. So let's say I make a move on these two. So it will become something like this. Like 1 from this 2 comes here. So it becomes 1 and 1. Then I just push this 1 here. So it becomes 1, 0, 1, minus 2. Then I push this 1, this minus 2. So it becomes 1, 0, 0, and minus 1. And still this is negative. So again, we'll just try to take one more 1 from this. So it will take 3 more moves. And finally it will become 0, 0, 0, 0, as we can see. So if you can visualize it correctly, we are just kind of bubbling. We are kind of bubbling the heat from one point to the other, right? So let's say I have some 1 here, then I have some zeros here, and I have this minus 1 here. I have like this is index I, this is index j. Okay. So can you guys tell me that how much time will I require for this to bubble this 1 up to here? How much time will I require? Tell me, guys. Like first I will need to bubble this 1 to here. Then from here I need to move it to here. 5. Yeah, I mean, in terms of I and j, if this index is I, this index is j, then how much time will I need to bubble this 1 up to this minus 1? Like for I and j, any general I and j? not just for this example, j minus I. Yes, correct. And let's say not minus 1. Let's say I had some k. I had some k here, then some zeros here, and then I had a minus k here. Okay. Index of this is I, and this is j. So how much time would I require to neutralize this case? K into j minus I. Yes. So this is like the problem is solved now. Basically, the algorithm goes like what will you do? Suppose you traverse through the array. I'll just take a test case and exam. I'll take an example and explain it. Let's say this one. Okay, you couldn't understand this test case, so let's just take this one. So this is actually quite a long one, but okay, no problem. 60030 minus 4. Actually, we'll take this sometime later. First, I'll just explain through a basic one. Okay, what you can actually do. Let's say we take. I'll just make my own one. 2010 minus 1 minus 2. Let's say this is the case. So, what will you guys do? First of all, I think it is obvious that you need to neutralize this 1 and this minus 1. Yeah, so you will do that. It will take how much time? It will take 2 time because j minus I into k. So after 2 time, it will become like this: zeros, 2 0 0 0 0 and minus 2. And then you will neutralize this 2 and minus 2. So this will take how much time? Uh, 5 into 2, 10 time, right? It will take 10 time and the array will become 0 0 0 0 0 0. So your answer is 12. But let's take a more complex case. Let's say we have 2 0 0 1 0 minus 3. So in this case, what we can do is first we'll neutralize this 1 and minus 3. Like I'll bubble this 1 up to this minus 3, right? So how much time will that take? That will take 2 time. So 2 0 0 0 and this becomes minus 2 because this one gets added to minus 3, so it becomes minus 2, and this takes 2 time. And then we'll just merge this 2 into this minus 2. So it will take like it will now take how much time? 5 into 2, 10 time, right? So again, the answer is 12. So guys, what I am saying is that what if you combine 2 and 1 first? Yeah, okay, you can do that as well. That is no problem. But um, I am just doing it like this. Like my algorithm is that whenever I find a negative, or let's say I find anything, let's say I have this negative first, minus 2, minus 1, 1, and 2. So I found minus 2. I'm traversing through the array. I'm traversing through this array. So at first I found minus 2, but I had nothing positive to neutralize it with. Like in this to the left of minus 2, I didn't have anything positive to it. So therefore, I just kept moving on. I moved on to this minus 1. So this minus 1 is negative, but I don't have anything positive for to neutralize it, right? Then I count this one. So 1 is positive. Now to neutralize this one, I can actually use the negative ones because I have I have some negatives that I've encountered. So I'll just use them and I will neutralize this 0. Yeah, so we are combining the ones with different sign. That is a greedy approach, which will help us minimize the answer. So I'll just traverse through the array, and if I find if I find a negative one, let's say I find this negative, then I ask myself that do I have a positive in my bank that I can neutralize it with? But I don't have any positive right here, so I'll just move on, and I'll add this minus one to my bank. That in future I can use it, and I have to use it to neutralize someone else. So right now in my bank I have this minus two and then minus one. Now I reach one, which is positive. So in my bank I had this minus one, so I can use it to neutralize this one. So whatever the last element is in my bank, I will use that. So let's say I have minus one, minus two, 1 and 2. So I traverse the array. I have negative, but I don't have anything positive in my bank. I just add this minus 1 to my bank. Okay. So minus 1 is added. Then minus 2 negative. We can't do anything. Then 1. 1 is there, right? So we will just use the last negative that we added to our bank and use it to neutralize this one. So the last element will become minus 1 actually, and this will become 0. This will become 2. Then I come across this 2. This is positive, and I have negative ones in a bank. These two minus ones. So I will use this last one to neutralize this. So this will become like minus 1, 0, 0, and 1. Now this is still positive, but I still have some negatives in my bank. So I will use those. I will use this again minus 1 to neutralize this. So it will be 0, 0, 0, 0. And we can calculate that in each step how much time we have taken, because that is just k into j minus I, right? So this is my algorithm. Now I'll just dry run it on the last test case, which was this one. I'll paste it here. I'll try to dry run on this. So let's say we have 6, 0, 0, 3, 0, minus 4, 0, 1, 0, 0, 0, minus 1, 0, 0, 4. Okay. So we have this test case, right? Now we have 6. This is positive, but we don't have anything negative in our bank. So we'll just add it to our bank. Then we have this 3. So we'll add this to our bank. Then we have this minus 4. Now minus 4 is negative. So we have something positive in our bank. So we'll use it. So we'll use this 3 to neutralize this minus 4. Right? So from our bank, this 3 gets lost, and this will take 6 time, because I'll have to move these 3 things to 2 places. I'll have to move these 3 things 2 places. So it will take this 6 time, right? So now in my bank, this 3 is gone. There was this 3 in my bank. Now it is gone. And this 4 has become minus 1. Okay. Now it is still negative, and I still have some positive in my bank. So I will use that positive. I'll use this 6 and to neutralize this minus 1. So to do that, I just need 1. I just need to transfer one element. So I just transfer this like this, and it will take like 1, 2, 3, 4, 5. It will take 5 seconds, and this bank will become 5. This minus 1 will become 0. So till now we have spent 11 seconds. Then I come up with this 1. So I'll add it to my bank because it is positive. Then there is minus 1. So it is negative, and I have some positive in my bank. I have this 1 in my bank. So I'll just remove that 1, and I'll add to the answer. I'll add 4 to the answer. 0, 1, 1, 2, 3, 4, right? So this minus 1 becomes 0. Wait, I copied it wrong. Okay, it is minus 10, not minus 1. My bad. So we still have 1 in our bank. We have this minus 10 here. So we have this minus 10, it is negative. So what we'll do is we'll use this 1 in our bank and it will become minus 9. And we can just add whatever the answer was, like distance between what was it? 1, 2, 3, 4. We'll add, yeah, 4 was added already. This 4 is added. It becomes minus 9. Then it is still negative. So we'll use this 5 that is in our bank. So we can use it to neutralize this minus 9. So it will become minus 4. And we'll take how much time? Um, we have to use this 5 from this zeros index, right? So zeros index to this index, the 12th index. So 60. Cool. And plus, okay, now we have nothing in our bank. Our bank is empty, but this is still negative. This is minus 4. So we'll just keep it in the bank and to neutralize something positive that will come. Like if something positive comes in the end, then you can use this negative to neutralize it. So we just put minus 4 in the bank and traverse to this 4. So I can see that this 4 is there and I want to find the neutralize it. So I will use this minus 4s and move them 2 steps here. So I will add 8. 4 into 2, 8. So the answer becomes this 6 plus 5, 11, 15, 23, 6. Okay, I have messed up somewhere. But I get like you get the idea, right? If you get this, if you do the same thing properly, then you will get 78. I assure you. I did that during the contest, but right now I just messed up somewhere. Do you want me to really do it, or do you get the idea and you can do it by yourself? Okay, I'll do it for you. Fine. No, it's not a typo. The answer is correct. I'll prove how. 6003 um, minus 4. I'll just omit the zeros. No, I can't do that. No. Minus 4, 0, 1, 0, 0, 0. Minus 10, 0, 4. So, to calculate the answer, first we have 6 and 3 in our bag. Then we have this minus 4. So, we add 3 into 2, which is 6. So, this 3 disappears. This minus 4 becomes minus 1. Then we have to neutralize this minus 1 using this 6 in our bag. So 6 becomes 5 and this will take how much time? 1, 2, 3, 4, 5. Okay. So this minus 1 becomes 0. Then this is 1. 1 is positive, we can put it in a bag. Then we have this 0, 0, 0, minus 10. Now minus 10 we can neutralize using this 1. So 1, 2, 3 and 4. We will have to add 4 to our answer. Minus 1 becomes minus 9. And now we have 5 in our bag. So we can use this 5 and we can do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that's where I messed up. It is 11 steps. So 4 plus 55. So our bag becomes empty. This becomes minus 4. So minus 4 goes to our bag because we have no more positive elements. Then you come to this 4 and you use this. You use the minus 4 to neutralize this 4. Use the minus 4 that is in our bag and you use it to neutralize this 4. So you will take 8. So 6 plus 5 is 11 plus 4 15, 78. 78. So the answer is correct, obviously. Like in the problems that you get, the samples are Correct. Don't worry about that. So that's the algorithm. And in the implementation, it is just that we just keep a stack. Like we can, if we have some positive element and we don't have a negative, then we can just pop, like we can just put it in a stack. And we also have to throw its index. And using those indices, that index and that last element, we can do the neutralizing. It's just casework. It's simple to implement. You can use a stack or a vector. I'll just show you the code, how I implemented it. So I have these two vectors which act as my stack. It's negative and positive. Like if my bank is negative, like if the element is negative, then I push it into n neg, and if it is positive, then I push it into pos. Maybe it is not required, but I just did it. So I loop through the array, as I said. If a is equal to 0, then it doesn't matter. I continue. If a is less than 0, then I have to neutralize it with something positive. So while pos dot size, which means that while I have something in the bank which is positive, then two cases, either pos dot back dot first is greater than or equal to absolute of a of I. What this means is that um, this last element, that the element in the bank can entirely neutralize this AI, then this is that case. And if it cannot neutralize that AI, like it can only partially neutralize, then this is that case. And I just do this while either a of I is still negative, or and I am having something in the bank. So I just add the answer with absolute of, like, how many elements I want to take, I want to borrow into the j minus I thing. Like I minus pos dot back dot second. Like I am storing in the first one, I am storing the value, and in second one I am storing the index. Yes, I will share the code. You will find it under the YouTube description, or maybe I can send it in the chat. I will do that. Okay. So yeah, this is just casework. So uh, this is that case. This is the another case, and yeah, even after neutralizing, if it is not equal to 0, then just push it. Like if it is still negative, even after spending entire bank, then just push into the negative bank. And the same thing, like the if else if a is less than 0, then this whole thing. And if a is greater than 0, that is if the element is positive, then you need to neutralize it with a negative bank. So the same thing, I just copy pasted it and just remove. I just did some changes to this whole thing and see out Hans. Yes, adding pause to pause or neck to neck doesn't make any sense. Yeah, like that will only increase the answer. You need to minimize the answers. Yeah. So I hope it is clear to everyone who is in this meeting. Okay, so if it is clear, then I guess I will end it unless you have any doubts. Do any of you have any doubt? No. All right then. Wait. Okay. Is there any prefix sum approach? I'm not sure. I haven't thought about that approach. Maybe there is in the solutions. Okay, in the solution they have used prefix sums. So I guess you can read this. I haven't read it. I haven't read it, so I don't think I can explain it. You guys can read it if you want. Yeah. Anyways, so okay, I'll just end the meeting. I'll see you guys next time. I hope you understood and enjoyed. Thank you. Bye.